So this video is going to be about adding and subtracting algebraic fractions, also called rational expressions. So first, let's talk a little bit about adding and subtracting. Then we'll talk about adding and subtracting fractions, and then how to do that with algebraic fractions. So, just in a kind of very simplistic way, let's talk about adding whole numbers here. So let's say we wanted to add 2 plus 3, right? So, start here at 2, take this distance of 3, and set it up on top of the 2, or on, alongside the 2, you know, so that we add the distance of 2 to the distance of 3, and we come out to 5. Okay? And subtraction works the same way. You just go backwards. Right? Okay, now let's talk about fractions. What if we wanted to add 1/2 plus 1/3? We're doing exactly the same thing. Here's 1/2. Here's 1/3. And so we do the same thing. We're going to take this distance of 1/3 and put it up here along with the 1/2, and this is 1/2 plus 1/3. Now the problem with adding and subtracting fractions is that we may not have the tick marks on our number line that tell us where our answer is. Here, if we're adding two whole numbers, we're always going to get another whole number, so we're going to know exactly where we are. With the fractions, where the tick marks fall is really entirely up to us. One fundamental idea, if you've never thought about it before, is that the denominator is intimately related to how many pieces we're splitting the number line up into between 0 and 1. So if it's 1/2, it's split in 2 pieces. If it's 1/3, it's split in 3 pieces. And so this idea of a common denominator allows us to create a common division of the number line. Okay, so when we create a common denominator, we're splitting all the thirds into half. Let's see, we'll make that 2/2. There we go. And we're splitting the halves into thirds. And so as a result of that, we see that the 1/2 is 3/6, the 1/3 is 2/6, and so the place where we end up when we add them together is 5/6. Okay? So that's just the whole point of making a common denominator. That's what I wanted to talk about as an introduction to this concept, is why do we make a common denominator? Okay? And this is why. We need to know where our answer is. If you've got a number line with pre-made tick marks that tells you where your answer is, then you don't need common denominators. Okay? Otherwise, we do. All right. Now let's talk about how to do this for algebraic fractions. So let's see. So this is the first part of section 1.7. And if you look at the exercises on page 62, it's split into 2 halves. And so I'm just going to be talking about the first half today. There'll be a quiz that goes along with that. And then I'll make another video to go over the second half, and there'll be a separate quiz to go over that. Okay, so let's look at problem 2. And like I said, these are on page 62. Problem 2, we're subtracting 3 over y minus 6, subtract 1 over y. Okay, now, just like the previous numerical problem where we had 1/2 plus 1/3, these denominators are both prime. And so the common denominator that we chose for them was just the product of one multiplied by the other. Okay? So we're going to do the same thing here. We're going to create a common denominator that is the product of these two things multiplied together, y times y minus 6. So over here, we're going to need to multiply by y over y. Over here, we multiply by y minus 6 over y minus 6. Okay? So if we do that, this one then becomes 3y over y times y minus 6 minus y minus 6 over y times y minus 6. Now that they have a common denominator, we can just subtract across the top. Now, something I'm going to point out here that's very important is that this subtraction has to get distributed like a -1 to both terms, both the y and the minus 6. And so when I write this, I frequently do it with parentheses around here because that reminds us to distribute that negative sign inside there. So now we'll have 3y minus y plus 6 on top. And so that'll be 2y plus 6 over y times y minus 6. You can factor this if you want to. This is 2 times y plus 3, but nothing's going to cancel. This actually is in lowest terms. Okay, and so we'll do more with reducing answers to lowest terms in the second half of this section 1.7. Excuse me. Okay, let's see here. Let's look at problem 4. All right, problem 4, we have 3 over x plus 4, subtract 4 over x minus 2. Okay, so again, both of these denominators are prime, and so our common denominator is going to be the product of the two of them, x plus 4 times x minus 2. So this fraction needs to get multiplied by x plus 4 over x plus 4. And this fraction over here needs to get multiplied by x minus 2 over x minus 2. Okay, so then as a result, what do we get? We get 3 times x minus 2 over x minus 2 times x plus 4, minus 4 times x plus 4 over that same common denominator. Okay, so now we can write this just as one fraction with the tops or numerators being subtracted, and then we have our common denominator, x minus 2 times x plus 4. Common mistake that people make with this step right here is they want to try to cancel. This subtraction sign right here prevents you from canceling. Okay, you can't do any canceling with these because they are not factors. All right, they're involved in this subtraction. Down here, you can cancel one of these because what's happening is multiplication. So that's what we talked about in the previous section. What we need to do at this point is distribute and combine like terms. So that'll be 3x minus 6 minus 4x minus 16. This stays the way that it is. And so we end up with negative 1x minus 22 on top, and then x minus 2 times x plus 4 on the bottom. Okay. Let's see here. Now let's look at an example from this section. Let's see. Section 1.7 starts on page 58. And as always, I encourage you to read through this. I'm going to look at this example on page 59. So let's see here. And so this one is 6 over x plus 1 minus x plus 5 over x minus 2. Okay, similar setup. These two denominators are both prime. They can't be broken down. They don't share any common factors. And so as a result, our common denominator is going to be the product, each one multiplied by the other. So this fraction needs to get multiplied by x minus 2 over x minus 2. And this one has to get multiplied by x plus 1 over x plus 1. Okay, so 6 times x minus 2 over x minus 2 times x plus 1 minus x plus 5 times x plus 1 over x minus 2 times x plus 1. Now, in this stage right here, you could cancel these out, but all that would do is destroy the common denominator that you've just built. Okay, all it does is take you back here. Same thing with these. You can cancel those x minus 2's, but all it does is bring you back to 6 over x plus 1. The whole point is to make this common denominator so that we can subtract these fractions. You can multiply this out if you want to. I'm going to rewrite this as a single fraction before I do the distributing and collecting of like terms. Okay. And again, right here, you can't cancel because of this subtraction. All right, what we need to do here is distribute. Okay, and so these two are going to get multiplied by each other as well. So let's see here. This will be 6x minus 12, and then I'm not going to lose the parentheses. This is going to start out x squared plus 6x plus 5. Let's see here. I'm kind of out of room, so let's move up here. This negative sign right here has to get distributed for us to combine like terms. So we're going to have 6x minus 12 minus x squared minus 6x minus 5 over x minus 2 times x plus 1. Let's see, those make 0. So we end up with negative x squared minus 17 over x minus 2 times x plus 1. And again, that's in lowest terms. In the first half of this section, 1.7, most of these answers that we get will be in lowest terms. You won't have to worry about reducing. In the second half, we'll see a number of problems where the answers have to be reduced in the end. Okay, let's look at a couple more examples. Okay, let's see. Back on page 62, let's do problem 10. Or let's do problem, let's see. Yeah, let's do problem 10. We'll go back and do problem 8 in a minute. Problem 10, 9y over y minus 4 minus y plus 1 over y plus 5. And again, like most of the problems in this first half of section 1.7, these two denominators are prime, and so our common denominator is going to be each one multiplied by the other. So this one gets multiplied by y plus 5 over y plus 5, and this one gets multiplied by y minus 4 over y minus 4. Okay, so then we've got our common denominator, and up here 9y times y plus 5. Over here we've got the same denominator, and then y plus 1 times y minus 4. Okay, let's see here. So now I'm going to write this as a single fraction with that common denominator y plus 5 times y minus 4. And again, you can't cancel here because of this subtraction. What we need to do is distribute. So 9y squared plus 45y, and then minus parentheses, y squared minus 3y minus 4, and then we've got our common denominator right here. Okay? Now, the parentheses are important because that minus sign has to get distributed inside the parentheses. So we come out of this with 9y squared plus 45y minus y squared plus 3y plus 4. And then we've got our denominator. And so now if we collect our like terms, we'll have 8y squared, 48y, and 4. And again, you can factor out a 4 from up here, but it's not going to cancel with anything. Okay? This answer right here is in lowest terms. If you want to factor the 4 out, that's fine. There's nothing wrong about it. It's not going to lead to reducing the fraction. Okay? This answer is just as right as the answer with the 4 factored out. All right. Let's look at one more. Talk about number 8. Number 8's a little bit different from the other problems, and it kind of gives us a preview of what we'll talk about in the second half of section 1.7. Let's see here. Oh, so before we talk about problem 8, let's look at a slightly different numerical fraction problem. Let's say instead of a half and a third, we wanted to add 1/6 plus 1/3. Okay? Now in this case, we could just multiply by 3 over 3, right? And we could multiply by 6 over 6 here. And so this would then be 3 over 18 plus 6 over 18 is 9 over 18, which is a half. Okay? There's nothing wrong with that. It's just that reducing these fractions becomes more and more challenging when we're working with the algebraic fractions. Okay? So, let's see here. What if, though, we wanted to add 1/6 plus 1/3? Now notice how the 3 is a prime number. I keep pointing out that our denominators are prime, and so we had to do this process. But in this case right here, the 6 is not prime. This is 2 times 3. We can turn this denominator into a 6. This could be our common denominator, right? We could just keep the 6 here. And then this one would be 2 over 6. And now when we add them, we get 3 over 6. We still have to reduce it, but notice that the numbers are smaller. And that's not so important in this particular problem, but in the problems with the algebraic fractions, it will be a much bigger issue. Okay? And so that's the way number 8 is going to work, and also some of these other problems that we're going to look at in the second half of section 1.7 is that one of the fractions will have our common denominator, and then we're going to take the other one and turn it into that denominator. So let's take a look at problem 8. Okay. Problem 8 is x over x squared minus 1 plus 4 over x plus 1. Okay, so this denominator is prime. There's no factorization that we can do here. Okay, but notice that the other denominator is not prime. This is a difference of squares. It factors as x plus 1 times x minus 1. This is going to be our common denominator. Okay, we're going to turn this one into this one by multiplying by the missing factor, x minus 1. So this one needs to get multiplied by x minus 1 over x minus 1. This one stays the same. So this will be x over, I'll write it as x plus 1 times x minus 1. And then plus, we will have 4 times x minus 1 over x plus 1 times x minus 1. And then we'll write it as a single fraction. Remember, you can't cancel those. Here, it's a plus sign that's preventing us from doing that. So we're going to distribute here. We'll get x plus 4x minus 4 over x plus 1 times x minus 1. And so this will be 5x minus 4 on top, and x plus 1 times x minus 1 on the bottom. Okay, so that's it for the first half of section 1.7. We'll come back with another video and finish up this section in a little bit.